So in the previous video, we evaluated functions for numerical values. You can also evaluate functions for algebraic expressions, okay? And as you get ready to move into calculus, you're going to see this is used quite a bit, especially when we're finding the limit definition of the derivative, okay? So let's start with a real basic one. Let's evaluate this function, same function from the previous video. We're going to replace x with a this time, okay? So everywhere we see an a, everywhere we see an x in my original function, I'm going to replace that with a, okay? Just some real basic cleanup here. So f of a is going to equal 3a squared plus a minus 5. So notice it's the exact same function, we're just using a different variable, okay? So nothing really difficult about that. There's nothing really to simplify other than squaring this a to get rid of the parentheses, okay? All right, if we want to evaluate f of negative a, so everywhere we see an x in our original function, we're going to replace that with negative a. So a little more cleanup here. So f of negative a, I'm going to square this negative a, that's going to give me a squared, and I'm just going to eliminate parentheses here. So this one's pretty easy too. So f of negative a is going to equal 3a squared. This is going to be minus a. Make sure you don't miss this sign. That's going to be a common place to make errors. And then minus 5. Okay, so notice the slight difference between these two. When I evaluate f of a, my signs all stay the same from the original function. When I evaluate f of negative a, this middle sign changed. So just a slight difference there. Okay, now let's plug in a binomial. F of a plus h. All right, so everywhere I see an x in my original function, I'm going to replace that with a plus h. So there's a little more work to do here. All right, so notice I'm going to square this binomial, and I'm going to eliminate parentheses here. So what that gives me, when I square the binomial, remember I'm going to square the first term, so a squared comes here. I'm going to multiply these two terms together. A times h is ah, and then I'm going to double that, so times 2. So that's where the 2ah comes from. And then I'm going to square the last term of the binomial. So that's why we've got h squared here, okay? So what's in parentheses here is just squaring the binomial a plus h. Again, from here to here, I just eliminated parentheses, and then I bring down the negative 5, okay? Now I want to use the distributive property, okay? So when I distribute, I get 3a squared plus 6ah plus 3h squared. Notice this is the result of the distributive property. Everything else, I just brought that down. Notice there are no like terms here, so there's nothing else I can do to simplify that. So f of the binomial a plus h equals this polynomial, 3a squared plus 6ah plus 3h squared plus a plus h minus 5, okay? Now, if you look at D, notice the numerator, we've already found both these values. I've already found f of a plus h. That's here. I've already found f of a. That's here. So let's don't reinvent the wheel here. Let's just plug in the values. Let's substitute the values that we've already found and make life easier on us. So f of a plus h, I'm just replacing that with the polynomial I just found. So notice this matches with what's in red here. F of a, I'm going to replace with 3a squared plus a minus 5. Okay, and notice there's a minus sign in between those two. And then my denominator is going to be h. There is no f of anything down here. H is h. All right. Now again, you're going to see this in calculus when you get there. So it's very important to be able to do this process. Okay. So now then, if you'll notice, I've got this polynomial minus this polynomial. And you should notice that there are some matching terms there. So 3a squared minus 3a squared. Well, those are going to cancel out. Okay? I've got a positive a here minus another positive a here. Well, those should cancel out. And then I've got a negative 5 minus a negative 5 here. And those should cancel out. So I've already simplified the numerator quite a bit. And what I'm left with in the numerator is 6ah plus 3h squared plus h, all that divided by h in the denominator, okay? So let's look at this numerator. They all have an h in common, so I'm going to be able to factor that out. Okay, so let's factor out an h. Okay, then inside we're left with 6a plus 3h plus 1. Okay, now I've got an h in the numerator, I've got an h in the denominator. Those are going to cancel out. And so you can see when I evaluate this whole thing, I'm left with 6a plus 3h plus 1. Okay, again, I can't stress enough. You're going to see this when you're doing the limit definition of the derivative once you get to AP Calc. So make sure you know how to do this process, okay? You're going to use this term eventually to help you find the derivative of a function like 3x squared plus x minus 5, okay? All right, so that's how you evaluate functions for algebraic expressions.